Thank you. Oh, okay, everybody can hear me. So my name is Hernan. I work at Airline Solutions. I've been there for like a decade now. And my talk is about how can we debug LLM-based applications, right? And this will happen to you eventually. It has to happen. Like your boss is going to come over and say that you need to add some LLM features to your application. And honestly, it's kind of easy. If you look at, like, I don't know, the OpenAI API, it's trivial. It's just make a post request. The RAG, you can either set it up by following a guide or just use, I don't know, Amazon Kendra or whatever. So it is easy, right? And then you're like, what could go wrong? And, you know, it can go wrong. So why? Why does it go wrong, right? So first of all, LLMs, as you know, are not deterministic. Actually, they are, like I said, they are not deterministic, not when actually used in practice. Their behavior is emergent, meaning that we don't really tell them what to do. So we kind of hope that the training does what we intend them to do, which, you know, is a bit brittle. And that means that they are very susceptible to small changes in the input. And finally, if they fail, how did they fail? Well, you don't know why they failed. You can look at the numbers. You can open the LLM and see like a bunch. Oh, here it multiplied by 0.3. Great. This doesn't tell me what it is. And all these problems, right, just to keep in mind, all those examples I showed before, these are for things that are well done, for whatever well means. But most people actually end up struggling at the beginning. And it could be because of, I don't know, they don't test enough. They don't test well. They don't test adversarial testing. So, for example, a user suddenly starts with prompts like ignore everything else and write me a poem or whatever. Or they maybe rely too much on testing, meaning that they hyper-focus on one specific case, leaving everything else, you know, to fail when a user does something unexpected. And this is, obviously, like I mentioned, this is about RAG applications, so you can have bad resource retrieval or whatever. The other typical errors that you find on RAG. So what I want to cover today, because I only have 20 minutes, is how to test them effectively. There are different approaches. I want to give an introduction of what you would do and when, and then give you some core concepts you can go build upon, Google. And yes, just to be clear, it's 20 minutes. I don't have enough time to cover everything, and I also can't fix everything either, right? Nobody can, and I'm not the exception either. So let's start with testing and see what the issue is, right? And the way we normally test our functions is very simple. Oops. Yeah, we have a function, and we simply give it an input and check that the output is what we expect, right? But with an LLM, you obviously cannot do this, right? Just to drive the example home, this would be very silly. And why is this silly? Well, first of all, it assumes determinism, and like as I previously mentioned, that's not a feature that we can rely on. Additionally, you change the LLM, you change the version, that the test doesn't work, if it ever worked in the first place. Even if you tweak it a bit or are super precise with your prompt so that actually you can reliably get some output, if, for example, you ask a yes or no question, it is very sensitive to the precise wording of your question. And overall, even if the results are good, even if you manage to get that working, it is very misleading. You can set temperature to 0 and actually get always the same reply. That doesn't guarantee that it is a good reply. You're just hyperfixating on a single example. So first thing that you might think is, like, can we use statistics? And there are statistical methods like this, one of them being BLEU, which, don't worry much about the code, but the idea is that BLEU gives you a similarity score between two sentences, between 0 and 1. This is significantly better than what we did before. And it's an algorithm from 2001, so it's not that old, actually. And yeah, it uses n-grams, basically sequences of words. So if you think of a sentence like the sky is blue, the sky is those two words in a 2-gram, and then it sees if sky is somewhere in the other sentence, right? Then it scores it based on this, and normally what you do is you give it a list of sentences you are okay with as replies, plus the actual reply you got, and then you score it, right? Is it similar to any of them? This is very fast. actually very fast. It's super simple to understand. Like, actually, you could code this if you follow the, if you see the statistical method it uses. Honestly, you can code it in a couple hours. It is language agnostic, actually, unless you're talking about languages with ideograms, in which case this actually is pretty terrible. And it is very deterministic, which is great because, few things on LLMs are. However, it is very sensitive to phrasing, so your reply might be completely correct, but if it's phrased slightly different, then it's not going to give you a good score, even though it should. It penalizes brevity. Actually, this works better, or better put, it has higher human correlation when the sentences you're comparing are rather long. Semantics don't matter, so you can change the entire meaning of a sentence by adding the word no somewhere there. This doesn't care really. All it would see is that this token doesn't, this word doesn't exist elsewhere. So it ignores this. The sky is blue and the sky is not blue are really similar phrases according to BLEU. And like I said, this has poor human correlation. There are alternatives to BLEU. There are a few. They all have the same problem. And I'm not saying these are useless, just to be clear. They cannot be used to check the output directly. You can use this to check, for example, if your LLM is hallucinating or using the context provided from the RAG. They are not useless, just want to make that clear. But yeah, it's not the main thing that we're going to use to test it. And the best way to try to face this is, okay, let's first go back to basics. Let's understand what we're doing. And what we're doing is not this. This is not the part what I mean. And neither is this, and understanding how the LLM works underneath. What I want to show is the basic flow, and then see what ideas can we get from that basic flow that maybe can help us test and how these ideas have been built lately. So if the user has a question, what first happens is it gets tokenized, and every word has a token. Actually, not every word part and punctuation, but every word has a token. We pass this to the LLM, which for all our purposes today is a black box, and this will return a series of tokens with weights. From this, we do sampling, which I don't want to get too deep into, but basically, this ends up choosing some of the tokens, because the LLM will return a vector with every single token it knows about. And this finally goes to the tokenizer again, and then we convert them to words. We get the percentages, we roll a dice, trying to do a weighted, random from those, and that's the next token, and then we keep generating, right? And if you have the RAG, a RAG application, the works sort of the same way. We start with the user question, we send it to both the tokenizer, like before, and the RAG. And then both go to the LLM. Normally, you would put the RAG stuff, for example, as system instructions, let's say. And then it works the same as before. And the final concept I wanted to show today is what the RAG actually really does, which is, for the question, it tokenizes it. It encodes it. This means every single token has a position in a hyperdimensional space, meaning that it has way too many dimensions to count. And the idea is that similar concepts are nearby in this space, so the distance between them is rather small. So then you do something called pooling. So you're doing token by token, but you have a full sentence. So for example, a classic way to do pooling to get a single vector out of all of this is get the average. That is a mean pooling, and it's actually the most common way to do this. And then you go to the database with this vector and say, hey, do you have anything whose vectors are relatively similar to this? And you would use like cosine similarity for this, for example, but the idea is the same. Like the distance is what matters, right? So armed with this understanding, maybe the most obvious answer is, okay, so words didn't work, and you also said that it doesn't work like in Chinese or whatever. So what about using the tokens, like our LLM is doing, or actually better put, like the RAG is doing? And that is actually what BERT score is. BERT score, the implementation here looks identical to what I did with BLEU. BERT score also returns a value between 0 and 1, scoring the similarity. And it's from 2019. And I highlight the year to show this is really new. And there are other tools that that are 1-2 years old. So there's so much more that people are learning on this, right? So they're always coming up with new ideas and new ways to test this. So like I said, this is very similar to BLEU. And the way it works, if you're curious, is we take every single token with their embedding, and then we compare to every other token in the other sentence. Basically, we're seeing, like, are the tokens or related concepts appearing on the other? This is actually simple to understand. I know I didn't do the best job of explaining it, but I am, I'm rushing, I'm sorry. And you can also put, like, for example, extra weight if the word is rare. Normally, you can tell that because the token number is really high. And it actually has pretty decent what's called human correlation, which is, if you were to do this on your own and say, how similar do you think these sentences are, you would probably agree with BERT score most of the time. It is, however, slower than BLEU. Still, we are ignoring the sentence structure. Like I said, we take all the tokens in the word and then see if they appear on the other sentence. It doesn't matter the order. Like, you could literally shuffle every word and the score wouldn't change. And again, imagine no somewhere in there. That automatically ruins the functionality of this. And it is language specific, meaning that when you tokenize it, you need to use the correct tokenizer. And when you calculate the embedding, you need to use the correct embedding for your language. And there are multiple embeddings for your language, probably depending on the resources you have to spare and things like the domain-specific stuff that you're doing, right? Like, if you're going to do something about engineering, it's not the same as if you're trying to do biology, right? And either way, all these cons actually make sense because all of these tools are translation tools. And suddenly it makes more sense, right, that they are trying to compare the similarity of sentences, because when you translate something, the list of reasonable translations is actually rather small, and you wouldn't expect your translation software to include a no or negate some things randomly, right? So, okay, so that is not a dead end. This is still useful. In fact, it's a bit more useful if you're going to compare to BLEU. I would prefer BERT score. This is still useful, but it's still not the silver bullet. And another idea could be using the token probability. So when we're talking about the way that the LLM generates stuff, one thing is that every token gets a percentage probability, a logarithmic probability really technically, but a percentage probability. And we can use this to know how much uncertainty do we have in the response. So if the LLM gives you a reply and all the probabilities are rather low, now you know that you were like a small roll of dice away from having a completely separate answer, a completely different answer, sorry. This is not correctness, and it's not accuracy. It's just uncertainty. It's not the same thing. But you can use it, but you can use it to know when your response is brittle, right? Like, if all the percentages are really low, then now you know that if you give the same prompt to the LLM, it might reply something completely different. So another thing to keep in mind is this one. They have to, because of the way they generate with the percentage, if you say, hey, what do you think about this? The percentages will line up. So you also probably want to, you use one LLM to test another with low probabilities. And this leads us to the last thing that I want to talk about, which is how do we fix this? We can call it this, LLM as a judge, right? This is the official name of us in ChatGPT. And it actually has really high human correlation. It is pretty good at that, as you may know if you have used ChatGPT at any point. It does consider semantics, which is great. And it can consider multiple dimensions. Like, you can ask, is this good for different reasons, right? Like, is this correct? Is this similar to this? Did you actually use the knowledge from the RAG and so on? But it's still not perfect. It can be expensive. Actually, it can get really expensive depending on how you run it. It's still susceptible to biases and hallucinations. Like, you're trying to test for this, and then you're using another tool that has the same problems, actually the same tool even. It also has a preference for style, which means, again, don't test an LLM with the same LLM you're using. And it is non-deterministic, which, again, a test that is not deterministic, like, you run it, and every time it gives you a different value. That is amazing, right? Like, who is reviewing this LLM? So we can still use it. It's still useful. So we can minimize these issues, for example, by making the problem space smaller, right? Just ask a Boolean question, maybe an enum, if you will. With the structure output, actually, you can use enums very easily. Also, if your LLM doesn't allow structure outputs, it's terrible. Use something else. You can break the evaluation into multiple criteria. So like I said, don't ask, instead of asking like, is this a good answer, and is it correct, and is the tone right, and did it do exactly what the user said, and so on. Just, do many of these tasks one by one. And then obviously log all the information. So for example, using structured output, one thing I like to do is ask for a reasoning for this, right? Tell the LLM to explain why it chose this in a simple string, and then you log that. If it's judging in a weird way, there you go. Just look at what it did, right? And yeah, like I said, this one, I should have put it earlier. So some key ideas, like just quick ideas that you can use is like separate it into claims here, with a schema. I'm saying like, if you get this response, separate into multiple claims. So if I say Einstein was born in the 1800s in Germany, I think he was born in Germany, then Einstein was born in Germany and Einstein was born in 1800s. Those are two claims, and you can test those separately. And then again, you minimize the potential for errors here. Here I'm measuring them separately. For example, does the context support it, or does it appear in the ideal answer that we wanted? So things that we can measure is, are we answering the question of the user? Is that answer supported by the RAG, or did it basically hallucinate it? It doesn't matter if it's correct or not. Like, it could be correct, but if the source of this information is the training data that the LLM had, then you are more vulnerable to mistakes later, right? And then you have two here, they are together. You can compare the claims between the answer and the reference, and vice versa, false negatives and false positives. And that's usually what's called precision and recall. If you see those words, now you know. You can use log probabilities when judging. So if you ask a yes or no question, if they are, for example, the percentage probabilities of the LLM were 50%, then you're literally throwing a dice. Like, it is not better than throwing a dice, right? If it was going to reply 50-50 to yes or no. So you can use this to know when the tests themselves are not sure, and then either modify your tests or do something else. Like, maybe you need to test in a different method completely, right? And this to me is like the best way is just steal ideas. Like, they are open source, just go and copy what they're doing. And finally, my favorite is this. If you don't do this, you're gonna be surprised. Just answer yourself and see if your framework is giving your answer a high score or not. So yeah, that's it. Here you have, this is where I stole my stuff, like, basically. This is where I stole my ideas for which metrics to use, but there are way more. And yeah, I don't know if I made it on time.
Thank you. I think we have time for one quick question.
So the question is whether.
Oh,
sorry.
Go ahead.
So the question was whether all this stuff is depending on how the LLM does tokenizing. Yes, kind of. So when you're using the tokenizer, you need to make sure that the tokenizer is appropriate for your language and use case. So the answer is yes. However, if an LLM can only use one tokenizer, right? Like, every LLM is trained with a specific tokenizer. You can't just switch it. So if you have one tokenizer that returns in, let's say, it works very well in German, you can't just use the output of that for an LLM that was trained in something else. But yes, in particular, BERT score goes from disaster to pretty good when you use the right tokenizer and also the right embedding function, which I didn't go into that much detail. So yeah, you need to be careful with choosing that.
All right, thank you.